So, welcome you all to the last session of today. And this is a public lecture by Professor David Buckley. And in this line, I would like to invite CSR Director, Professor Amare, to introduce the speaker and invite him for a lecture. Thank you.
Thank you very much, Sunil. Welcome everybody for this public lecture. Those of you attending in person and on the virtual platform. Today we're privileged to have Professor David Buckley giving a talk on observatories, telescopes, and travels, a personal journey. I'll just briefly introduce Prof. Buckley. David has an MSc from the University of Canterbury, New Zealand, and a PhD from the Australian National University in Canberra, where he studied at the Mount Stromlo and Siding Spring observatories. In 1988, he took up a postdoctoral fellowship at the University of Cape Town before moving to the South African Astronomical Observatory in 1991, where he has worked ever since. David was the project scientist for the Southern African Large Telescope, SALT, during the design and construction phase from 1998 to 2005, and then appointed the first SALT Astronomy Operations Manager and SALT Science Director until 2015. In 2017, he was appointed as the first SAO Dara O'Donoghue astronomer and is currently also serving as the SALT Global Ambassador. His research has mostly focused on compact accreting binary stars, including X-ray binaries and cataclysmic variables, where he studies with both optical and ground-based facilities, such as SALT and other SAO telescopes, and UV or X-ray space-based telescopes. In 2013, he was the recipient of a C.V. Raman Senior Fellowship, where he visited the Tata Institute for Fundamental Research in Mumbai to formulate SALT AstroSat collaborations. His more recent research has focused on astrophysical transients, where he is the principal investigator of a large SALT program and a South African affiliate principal investigator on the Vera C. Rubin Observatory Legacy Survey of Space and Time. He's also an investigator in a number of international projects, recently being involved in leading a BRICS astronomy initiative to establish a flagship program on astrophysical transients and big data. David is also an expert on optical telescopes, instrumentation, and on astronomical site testing and characterization. In recent years, he has also assisted in astronomy capacity development in other African countries and has also been involved in projects to establish optical telescopes on the continent and to network existing ones. He's also currently chair of the Science Committee of the African Astronomical Society, AFAS. He currently has a total of over 300 referred publications with over 11,000 citations. In 2021, he was appointed as an honorary research affiliate at the University of Cape Town and as an affiliate professor at the University of the Free State. With that, I hereby invite Professor David Buckley to give his public lecture.
Thank you very much. Thank you very much for that very nice introduction. So this is quite an odd lecture because there's no science in this, or very little science in this. And it's a very personal talk as well, because when Sunil approached me, he said, I'd like you to give a talk to the students about all the interesting places you've been to around the world to do with astronomy and telescopes. So that's really what this talk is all about. It's my own personal journey, and starting from the very first days. Oh dear, this is not working, Sunil. and the banner is back up. I don't think it's in full presentation mode, is it? So I'm going to start from the very beginning, which is when I first started to become interested in astronomy. And that was about age 7, when I had a book that my father had on astronomy. And for my 7th birthday, he bought me a telescope, a little 60mm telescope. And okay, we seem to have that banner at the top. I don't know how you get that to disappear, but anyway, so I had this small refractor, and I used to go to the planetarium, and so I really started to sort of go to the library and take out astronomy books. One of the first ones I remember was Patrick Moore, a UK, British astronomer who had all of these books, and the one I had was called Astronomy for Boys, which I think is quite, in this day and age, quite politically incorrect. I don't think he wrote one for girls, and I don't know what the difference would have been, to be honest. But anyway, so then I joined the local astronomical society, and was a member of the so-called junior section, which were like school kids, even up to sort of university students as well. And eventually I moved up in the ranks of the society to become a treasurer, secretary and editor of their magazine. I visited this observatory at West Melton, which was just outside of Christchurch, which the Astronomical Society had built. And that was my first time ever to see a sort of proper telescope. Eventually, I got a better telescope by selling my train set and using the proceeds for that to get an equatorially mounted telescope. And I got, not only did I sell the proceeds of my model train set, but I also worked in the holidays raspberry picking and potato picking to earn enough to buy the telescope. But in the end, it was replaced by a much, much better one that was built in the 19th century, an old brass Dallmeyer telescope that was sitting in the lab of the physics classroom at my old high school and being threatened to be chucked out. And so I bought this telescope for $20 New Zealand. And I remember I had to approach someone in the society to write a letter to the school headmaster to say that I wasn't being fleeced at buying this telescope for $20. So yeah, I think it's okay, except for the thing at the top, but never mind. My activities in the Astronomical Society were to do with visual observations. I mean, just looking at variable stars and estimating their brightness by eye. Then I started to look at using telescopes to actually make photometric observations, sort of serious photometry with a photoelectric photometer, which at that time, this is pre-computers. So you had this sort of a meter, a count meter. You press the button and it would integrate the counts for a certain length of time. And then you had to write it down on a piece of paper, both the time and the counts. So it was quite challenging, but nonetheless enjoyable. And I spent many weekends and holidays out at the observatory doing this sort of thing, and eventually had my first publication in the magazine called Sky and Telescope, which was, I think, on comets and an asteroid or something. Oh, and also looking at the aurora. So this photo here is sort of interesting that it shows me circled there, but also another guy here who was several years younger than me, Sean Ryan, who's now the head of the astronomy group at the University of Hertfordshire. So some of us have carried on in careers in astronomy, and there's also another guy who wasn't in this photograph who's at St Andrews. So you know, I think I at least, this isn't working. So these were sort of my formative years as a school kid in astronomy, and unashamedly sort of nerdy, but nonetheless, you know, this has really became my passion. So when I started my academic studies at the University of Canterbury, I enrolled for a BSc in maths and physics. Actually, I started off doing chemistry because in high school, I was really keen on chemistry. I had this chemistry lab that was in half the chicken house. So we had this sort of hen house, and I evicted half the chickens and built my lab there, much to my mother's consternation, because there was frequently various experiments where the chickens sort of were somewhat overwhelmed by like clouds of chlorine gas and other things. But so when I went to university, I thought I'd do chemistry, but then first year of chemistry I found quite boring, so I ended up doing physics and maths. And during that time, I was also using this telescope called the Townsend Observatory, which was in the old university in the center of the city. They moved out to the out into the suburbs in the 60s, but this old sort of mock Gothic stone university buildings were turned into what was called the Arts Centre, and the observatory was still operating, and I was doing the sort of Friday night observing for the public, and also at the same time on Sunday afternoons, every so often would do lectures in the planetarium. Unfortunately, the whole telescope was destroyed, or the observatory was destroyed in the earthquake in Christchurch in 2012. You can see the tower here has just sort of collapsed. Amazingly, the objective lens of the telescope was not destroyed. And so one of the technicians in the physics department actually put it together and successfully rebuilt it. And the tower has been rebuilt, and now it's back into operation. The only sad thing is that all of these buildings here, I mean, all of the rooms below here, which were various sort of interesting rooms that artists and other people used, is now a very expensive hotel that no one can afford to go to, I think. I also helped get my hands on doing optics by helping Gary Nankerville, who is New Zealand's preeminent optical fabricator, who built a 1 meter telescope for the University of Canterbury. So that was my first foray into understanding and doing things to do with optics. And then when I finished my undergraduate degree, was at a time when they were introducing for the first time a master's course in astronomy. And so I think I was the first student to do that master's degree in astronomy rather than physics, which took me to the observatory that the University of Canterbury ran in the South Island of New Zealand, where the dot is there, called Mount John Observatory. It was founded in 1965 between the University of Canterbury and two US universities, University of Pennsylvania, University of Florida. So I cut my teeth on optical photometry using two different telescopes. I also did a little bit of spectroscopic observations as well. And that was a fun time. I took much longer than I should have done to do my master's degree, because in those days it was not so much pressure on you. And so I did a over 250-page master's degree on modeling, well, observing and then modeling eclipsing binary stars. So I learned the fine art and demands of optical photometry, and under the banner, because it's blocking it here, I also learned to ski at that time. You can see that sometimes Mount John was inundated by snow in the winter months. So I did my master's degree on eclipsing binaries, observed about a dozen of them, used various codes to model and get the parameters from them. And then presented it at a conference, my first conference I ever went to, which was in Indonesia in 1983, I think it was. And then it was subsequently published. And this is a photograph which is fortunately very small, so you can't see this very nerdish, beardless wonder in the red t-shirt. I should say that at that meeting, I met some famous astronomers. Denik Kapal, who was a theoretician, wrote a seminal book on close binary stars, developed all the theory of Roche equipotentials, hated people talking about filling the Roche lobe. He didn't like that at all because the Roche geometry is for point masses and real stars have a distribution of mass with radius. So he would correct people when they say Roche lobe overflow. No, it's the equipotential, it's the critical equipotential surface overflow. Anyway, that's neither here nor there. Bart Bock was actually also another astronomer that was at that meeting, a previous director of Mount Stromlo. As just as an aside, and I'm going to wander off this sort of chronological journey from time to time. Now, New Zealand has much larger telescopes at Mount John. The largest is this 1.8 meter MOA telescope, as it's called. It's a collaboration between Japan and New Zealand on microlensing for exoplanets. The 1 meter telescope that you saw me assisting with the final polishing eventually ended up here, commissioned in 1986, and then added a very nice instrument here, a vacuum stabilized fiber fed shell spectrograph. So New Zealand has added facilities, but it is still, a small country in terms of astronomy. So my next step was to move to Australia, where I succeeded in getting a scholarship at the Australian National University, and I started my PhD studies, and it was on X-ray sources. X-ray sources from a satellite called HEO-1, which we haven't heard about, I don't think, in this school yet, because it's one of these satellites that was before grazing incidence optics, where you could focus the X-rays. So this was a collaboration between my supervisor, Ian Toohey, who was an X-ray astronomer, and a group at MIT, Hale Bratt and Ron Remillard, who were at that time really interested to look at the sort of weak sources that had been detected by HEO-1. All the bright ones had been observed and lots of papers came out, but there were all these sources at the sort of 3 sigma level, which most people can't be bothered because it's quite an effort to try and study them and find their sort of optical counterparts. And so Hale Bratt just had this bright idea that let's try and do the southern objects from Australia. And so he was just in his office in Boston, and he just called up Ian Toohey right there and then, which of course was the middle of the night, and woke him up. But nonetheless, what came out of that was this collaboration between Ron and Hale and Ian Toohey, myself, and another guy, Roger Brissenden, who worked on the extragalactic sources. So this was basically doing follow-up on optical follow-up, identification of the counterparts, and then observing them to find out what their nature was. And it used a number of different facilities, including the Anglo-Australian telescope, a 3.6 meter telescope here. Actually, I think I've got that wrong. It's 3.9 meter. 1 meter telescope, and the old Mount Stromlo 74 inch, which for those of you who have been to Sutherland, this is exactly the same telescope model as the one in South Africa. So I focused on X-ray binaries, cataclysmic variables, and active corona stars in my thesis, and in the end published 5 papers out of that. And it was mostly photometry, spectroscopy, and in the case of the cataclysmic variables, some modeling as well. Now I'm going to go off into an aside on HEO-1, because this is, after all, an X-ray school. And so I think it's worth realizing what the challenges were back then before HEO2. Does anyone know what HEO2 was or became? I know that Matteo will know, or Carlos. Anyway, it became renamed the Einstein telescope. So what was the difference? Well, the difference was no focusing optics. So in the case of this big satellite, you can see it's quite large. It was one of the so-called great observatories, launched in 1977. So a long time before I started my work on using data from this satellite. And it had 4 different experiments. And the one that the MIT group were responsible for was the A3 experiment, which was called a scanning modulation collimator. And to cut a long story short, what it was a big proportional counter where you had a sort of field of view that's huge. Any X-ray coming into it would be absorbed, and you would get a signal from the ionization that happens of the noble gas inside this proportional counter, just like they have in physics, experiments. So that's no good because an X-ray could be coming from there or there, and you have no idea where it's coming from. But they did a clever thing. They put an array of wires in front of the collimator. So this little plot down here shows, you can see wires here if you're thinking of them going into the screen. So just like piano wires coming out with the separation about the same as about twice the thickness of the wire. And you had several layers of these. So the X-rays would only reach the detector if they went past the wires and eventually got into the detector. And then because the satellite was constantly spinning, because it was doing a survey of the sky, so it was going through the ecliptic poles all of the time in each survey. And so over 6 months, it would cover the whole sky, a bit like what eRosita does today, or did. So you would get a signal of your on your proportional counter that would be going up and down like this because of the modulation of the X-rays by the rotating wires. And then they did another clever thing to have 2 banks of detectors, two different collimators, 2 different proportional counters where the wires are slightly angled. And so what you ended up then with is something that looks like this, a map on the sky where you have all of these tiny little iridiamonds, about an arc minute in size, but distributed over many degrees. And the actual responsible source, or the counterpart, would have to be in one of those little iridiamonds. And you don't know which one. So my job in the first year of my PhD was, well, we took a lot of photographic plates. Okay, so I'm showing my age here. This is before CCDs. So this is photographic plates in using a Schmidt telescope, which is a wide field of view, taking ultraviolet exposures, which took an hour and a half, and then you change the filter, and you take a blue exposure with a blue filter, so you get the U and the B, ultraviolet and blue. And you needed that, but the ratio was like 90 minutes, an hour and a half for the U exposure, and 18 minutes for the B, because the sensitivity of the photographic plate is so pathetic. And in principle, you would then get an image of a star, which if it had a U minus B color of 0, in other words, in the same flux in U and B, you would see 2 equally exposed stars on your photographic plate. And so when we did these observations, we would take the U exposure, then we'd close the shutter, move the telescope a tiny bit, and then open the shutter. So you got pairs of these little U and B exposures. Then you're doing this all night long, and I'm doing it with a telescope that's got not the best telescope drive. It had errors, so you had to sometimes close the shutter and fix it and open it again. So very tedious observations, which then at the end of the night, you couldn't go to bed. You had to take these photographic plates to the darkroom and then process them. And then when you got up in the morning, you had to go and take the plates you were going to use that night and take them to a facility where you bake them at temperature in forming gas, which is a combination of nitrogen and hydrogen, which sensitizes the plates much better than if you just took them out of the box and stuck them in the telescope. So these were like really challenging observations. And then with these photographic plates, we would overlay these X-ray positions on a bit of a clear plastic and then go down into a basement with a microscope and a light table and look at these, every single one by eye, moving from one diamond to another, looking for, as Ron Remillard used to call it, the killer UV counterpart. And I tell you, this was the most tedious, boring, and turning off. I mean, you know, really that first year of my PhD was really, you know, not great, down in the basement looking at these photographic plates. So, yeah, so in the end, I basically looked at a number of different sources. This little example of that, you know, all of these little aerodiamonds here from the A3 experiment. In this case, it's a little bit fortunate that there's also another error box from another experiment that together sort of means that in principle, you only have to look at the ones inside the big box. So it's not quite as challenging. So out of this particular source, which was known as HO534, eventually renamed TWPIC because it was a variable star, it ended up being two chapters and 2 papers from my PhD in, I think, 1989 or something. I can't quite read what that says. 1990. And then just last year, Simone Scaringhi and a few of us worked on TESS observations of this object, which shows it to be far more interesting than just an intermediate polar, a magnetic CV. It's actually something that seems to show something called magnetic gating, but this is not a science talk, so I'm not going to talk about that. The bottom line was that HEO1 was the satellite that produced the first survey of the entire X-ray, or the most sensitive survey at that time. Uhuru did one as well, but this was about 1,000 sources covering the whole of the sky. And so that was sort of the outcome of the A1 experiment, which was the bulk of the resources of the HEO1 satellite were dedicated to this experiment built at the Naval Research Labs. And that was the catalog that came out. And it's just worth contrasting it with the ROSAT view of the sky that came in the early 1990s or mid 1990s, where 70,000 sources are in the ROSAT catalog. And then, of course, we're all quite familiar with the beautiful images now from eRosita. So once I'd moved after I finished my PhD and I went to South Africa, I actually worked on similar optical identifications and study of ROSAT sources, which was a lot easier because ROSAT was an imaging X-ray satellite. And that's the view that we've all seen now of this amazing view from the first 3.5 years of the eRosita survey, which is currently suspended because eRosita is a joint Russian-German collaboration. And after the invasion of the Ukraine, Max Planck said, okay, we'll put it in a safe mode and we're not going to use it. Anyway, back to my story of being a student in Australia at Mount Stromlo. We had it pretty nicely there. I mean, it was quite a pleasant place to work. It was outside of the city in a pine forest. Most students were able to stay on site in like shared houses. So the first house I stayed in was this one here, where I shared it with 2 other students and a cat that was eventually adopted, which is a funny story in that because the 2 of us weren't so keen on the cat and the 3rd guy was the one who really liked the cat. And we didn't notice for a while that it only had 3 legs. So we called it tripod. It obviously had its rear leg removed a long time ago because it was just not obvious that it was lacking the leg. And then when that guy went off to the Netherlands for a research trip for a few months, we didn't really want the cat around, so he got his parents to look after it in Perth. And at that time, it was a very fussy cat. It would only eat a certain sort of cat food that his parents weren't buying, but he insisted they buy it. So they did buy this new cat food, and they had a competition where they could fill in a label of this cat food, and they won $20,000 from this. So thereafter, that cat got exactly what it wanted. That's the 74-inch telescope. There's lots of other historical ones. Typical Stromlo party. I challenge you to see, well, to sort of identify where I might be in that, but I'll give you a clue later. Really regrettably, in 2003, Mount Stromlo was devastated by a fire, which destroyed the 74-inch telescope. This is the fire taken. You can see an aerial shot of one of the domes. This is an old refractor, about a 24-inch refractor, historical one that was completely destroyed. Ironically, a week before this fire reached the observatory, they had a dinner in this big telescope dome because they had a lot of floor space and they used to use it for functions. And they had a function for the fire brigades. And there's a photograph of these firefighters sitting at tables, eating their meal. And there's a window, because there are windows in this building. And in the distance, you could see the glow of the fire in the Brindabella Mountains 5 days before this fire became just a huge front and destroyed the observatory. Also destroyed, apart from the telescope, was this instrument called NIFS, a near-infrared spectrograph that had been built in the workshops at Mount Stromlo and was sitting on a pallet ready to be shipped to Chile, and the fire destroyed it. And yeah, very sad. Stromlo's been rebuilt today. So now there's a wonderful new high-tech state-of-the-art instrumentation and technology center. And I'm just showing this funny thing here that looks a bit like Arnold Schwarzenegger or the Terminator. What it is when they first, one of the first projects they did was to build SkyMapper, which is a wide field telescope at Siding Spring Observatory. And when they first got it running, they had terrible image quality. I mean, really, really awful image quality. And they realized that a lot of the various mechanical components of the telescope were not properly designed. So this has been built from all the rejected parts of SkyMapper and sits in the cafeteria at Stromlo. So then after Mount Stromlo, I moved to South Africa as a postdoc. And just to quickly summarize, from 88, end of 88, when I arrived, to mid-91, I was in the astronomy department at UCT working with Professor Brian Warner, who led an internationally recognized group working on cataclysmic variables. And I was, as I say, I started working on ROSAT sources and did a lot of work on magnetic CVs and pulsating white dwarfs and so on. Then in 91, I had the opportunity to take up a position at the South African Astronomical Observatory. So I moved there. That was when Michael Feast was still director of the observatory. And he wanted me to have involvement in what was being called SALT, the South African Large Telescope, because at that time, the 1.9 meter at Stromlo, at Sutherland was the largest in the country. And although South African observational astronomers were still sort of internationally competitive, because what they lacked for in aperture, they made up for in lots of observing time, because there weren't many astronomers back then. We still needed to look at the next phase of getting a larger telescope. And so when I joined the observatory, I was working with Ian Glass, who was a respected instrumentalist, infrared astronomer. And that's when my sort of foray into telescopes really started in earnest, and ended up with me becoming the project scientist for SALT once SALT was funded, well, even before it was funded, actually, from 1998 till when it was inaugurated in 2005. And then since then, I was during the sort of early operations phase for 10 years, I was the astronomy operations manager, and then later science director. So what is SALT? I think everyone really does know that it's one of the big five, one of the big 10-meter class telescopes, segmented mirror telescopes, of course, which were pioneered by the Keck telescopes in Hawaii, then followed by something called a Hobby-Eberle telescope, which was built in Texas, also 10 meters, but quite an innovative and cheaper design, which is why SALT could be afforded by South Africa. And so SALT is a sort of, if you like, a twin or cousin of the Hobby-Eberle telescope. And the last one to be built of these 10-meter segmented telescopes was Grantacan. So SALT is the only one of these in the Southern Hemisphere. And just to give you an idea of the sheer size of the mirror array, that's the 91 mirror segments that comprises SALT. But SALT in the beginning was not the SALT that we have now. The SALT in the beginning was going to be a 3.5-meter telescope, essentially a copy of the new technology telescope that had been built in Chile as a forerunner to the very large telescope, the VLT, trying out new technologies like active optics and thin mirror design. So the idea was that at that time there was interest by the Max Planck Society, because they owned this mountain called the Gamsberg in Namibia. And they already had a small telescope that had been operating there for many years. So the director of the time, El Sasa, was really keen to put a telescope on that and make it basically an NTT type telescope. So the idea was that they would pay for the telescope, South Africa would pay for the operations cost to run it, and the Namibian government would pay for the infrastructure to put in road, power, and all of that. So that all came crashing down in 1995 because of the fact that there was no longer interest within the Max Planck Society. It was a change in director. There was now emphasis by them to go into much bigger telescopes than just 4-meter. And the main driver was the LBT, the Large Binocular Telescope. But nonetheless, this was a place where I had a visit in '94 together with the then director of SAO, Bob Stobie, and we spent a week on top of that plateau with an instrument we built at SAO called a differential image motion monitor, where we made observations from the top of that plateau, together with observations that were being done by ESO, because at that time, ESO had not been given the final go-ahead to build the VLT at Paranal. There was a family in Chile who owned the mountain and were resisting the building of the mountain. And so the ESO were putting pressure on the Chilean government to do something about this. And it was all being dragged out somewhat. And so they made this sort of, I wouldn't say pretense, but they sent off sent an instrument to the Gamsberg and contracted a young engineer to make site testing measurements for about 18 months, with the idea that if they didn't build VLT in Paranal, they'd come and build it here. But it was a ruse, really, I think. And of course, we know BLT didn't end up in Chile. So that was the end of the first attempts of SALT in 1995. But what came about was that there was this new telescope that was built in Texas called the Hobby-Eberle telescope. That was really innovative design, very much a cost-saving design. And so we had a visit from the HET sort of project manager and the director of McDonald Observatory and the project scientist. And basically that idea of building a copy of HET in South Africa became the new SALT project. And so in March 1998, we had our first Science with SALT workshop, which was held in Cape Town. It brought together all of the astronomers in South Africa at the time. It also had people from the US community involved in HET, and also some US and European potential partners who were interested in the idea of joining with South Africa to build SALT. And we also had engineering companies, both South African and some of the companies involved in building HET in the US, have parallel sessions where they had technical engineering sessions about, you know, the capabilities of South African industry to take on this job. So I became the interim project scientist in 1998, appointed in November. Then over the following year or so, we were drumming up the support to, you know, get official signed letters from our partners. And that all happened by about a year and a bit later, where the government gave the green light for SALT to proceed. And at that point, we appointed the project manager, Kobus Mering, someone who worked in designing and building helicopters. And then we recruited the rest of the project team by about mid-2000. And then the groundbreaking ceremony was held in September of 2000, and the telescope was finally constructed and completed and opened in November 2005. And this is the project team here. And we never had a huge number of people. This is sort of the original ones, but we added maybe another 4 or 5 people to the team who were there doing sort of, I guess, brought in from time to time for software development and other things. So SALT was quite a new thing for all of us. I mean, it was new for me, it was new for the engineers, although they had the same design principles of what they were building. In like helicopters, they talk about first flight rather than first light for a telescope. But you know, it was something where there was clearly the capability there. You know, this was not something, I think, that was beyond South Africa, as was ultimately proven. But for the first year, people at the observatory wondered what the heck we were all doing, because we were just having endless meetings and so on. And this is the sort of process that you go through when you do what's called systems engineering design, where you do something and you have to sort of come up with some designs, do trade-off studies of what their technical, you know, what they have to achieve technically. And then, of course, the cost, because we were very much limited to a budget of something like 19.8 million US dollars. So there were lots of design review meetings. We all went, the project team went to the Hobby-Eberle telescope. This is us all meeting there with the engineers and sharing knowledge. They handed over lots of design documents, etc. Then we had design meetings back in South Africa, where we brought in external reviewers from major projects like Keck and other such projects. So out of that, we ended up, you know, getting a final specifications and detailed technical designs for the telescope. And a lot of what we put into this came about from visiting other telescopes. So we had an opportunity in the early 2000s to visit a number of different facilities in Hawaii, for example. We visited Gemini telescope, the Subaru telescope, Keck, and out of all of those visits, particularly Keck, because it was a segmented mirror telescope. So we learned a lot about how you control the alignment of the mirrors and the whole sort of business of dealing with a segmented mirror telescope, and to do with instruments as well. This is one of the instruments, LRIS on Keck, where some sort of some of the things that were done on those instruments were sort of utilized in the design of SALT instruments. We also went to La Palma, so looked at all of the telescopes there. The one that had, I think, the most traction with our engineers was something called the Nordic Optical Telescope, which boasts the best delivered image quality on La Palma, because it's right at the top of the caldera here, but also because it takes or took an innovative approach to making sure that there was no dome seeing by adequate ventilation, false floors, all of that sort of stuff. Although it is quite funny that, I mean, the NOT is a Scandinavian collaboration. It was done on a shoestring budget. And when we visited there, they were still running things using DOS machines, the DOS operating system on old IBM computers. Well, I mean, this is 2000, so, you know, okay, it's not that out of date, but their philosophy was, we're not going to be continuously upgrading our computers. It's fit for purpose. It does the job. We'll just buy umpteen spares of everything. So they had spares of all these sort of, well, almost obsolete then, but totally obsolete. I don't know now, I haven't been back to see if they're still running DOS machines. I somehow doubt it. The project team, as I say, was quite a small group of people. And basically it had sort of 5 main engineers, project managers for the different subsystems of the telescope, like the whole building, the mirror system, the telescope structure, the payload, which is where the instruments ride, because this telescope's different to your normal telescope, which is fully steerable. It's a bit like the Arecibo radio telescope with a fixed dish and a moving secondary and instrument. So it's the optical equivalent of that. So it was a sort of lean project team, and then it had sort of support people in terms of optical design people, control systems specialists, and a bunch of people that did software and other things. And so this is just a few photos that show the how it evolved over time. So that was what the site looked like before we started construction. There were only 4 telescopes at that time in Sutherland. And then this is the moving through the construction. And just over 2 years, the actual building was all completed and dome. And then the installation of the structure that holds the mirrors and the mirror mounts and the mirrors themselves, which the blanks were made by a company in Moscow called Elzos, which ended up providing a much cheaper and just as good material as the much more expensive shot equivalent Zero-Dur glass, which we were going to go with, and they gave us a verbal quote, which when they sent us a written quote went up by a factor of 2, which led us to go to the Russians to supply the mirror material. And we really were, I mean, this was one of the most successful contracts. They produced mirror blanks with coefficients of thermal expansion twice as good as what we'd specified, which helped with the error budget for the image quality. So those mirrors blanks were then sent to the US, to Eastman Kodak, where they were figured and polished and iron figured, and then sent to South Africa in batches of 7 at a time, typically. And by 2003, we had the first 7 and started to install them and even get first light with just several mirrors. And then by 2005, the whole thing was finished. All the mirrors were in place. We had the inauguration where the number of people who turned up was more than the population of Sutherland, and in a massive marquee at the top of the Sutherland Plateau, opened by the then President of South Africa, Thabo Mbeki. Building SALT was challenging for a lot of people, and these are just some amusing photographs. This is Dara O'Donoghue here, a really close friend and colleague of mine, who was very much involved in the optical design. And we worked long hours. All of the team worked long hours to see this project to completion. So yes, sometimes it was sort of quite tiring and challenging, but also it was great fun. We had a lot of parties and a lot of good humor happening during that time. This is me, by the way. The reality, though, was although we said we'd finished it in 2005 in November, there were still a lot of things that weren't what I would call finally up to spec. And it was partly a consequence of the fact that there was a limited budget, that the project team were not going to be extended to do the final completion jobs, which were handed over to operations staff. And so in the end, we probably spent another year or longer to get all the final things properly finished off. I mean, we had to abandon what we call a edge sensor, which measures the relative positions of all of those segments, because we were using a system that was based on the technology of Keck, which are capacitive sensors, but Keck is in a much drier environment than Sutherland. So we had to ditch that after about a year and a half trying and go to a whole new technology, which in the end worked out really well. And this little Dilbert cartoon just reflects the project manager, Kurbis, project scientist, myself, and maybe it's a bit mean on Kurbis, but there was always abundant optimism from the engineers that they would get the job done, and they did in the end. So life after SALT, well, it took a long time to move from like sort of partial science, so early days of early science, still commissioning, to full science operations, which was finally in 2011. After 2015, my role in the management of SALT ended, and I no longer had to manage people other than like students and so on, but no more sort of endless meetings, and I could go back to the reason why I got involved in SALT in the first place, to do astronomy. So I've been focusing on research ever since. Started up a program called the SALT Transient Program, which has been going since 2016. And again, focusing on the things that I've always been interested in, CVs and X-ray binaries and other related objects. And then more recently, I've been involved in also the Rubin Observatory, and also PIing a number of different bilateral and multilateral projects, including ones in India. And I'm still involved in student supervision. I currently have 6 PhD students and 1 MSc, and do occasional lectures for the master's program on compact binaries. I'm now going to go through some of the places that I've visited. And so I'm just starting with one where I actually went there to do observations, which was this telescope in Thailand. So interestingly, you can't really tell here, but I'm standing next to, this is a 2.4 meter telescope by the Thai National Telescope, which is actually on the tallest mountain in Thailand called Doi Inathon, 2,500 meters. It's in the Golden Triangle area of northern Thailand near Chiang Mai. And the director of it is this guy here. These are all staff of the observatory. Because they're civil servants in Thailand, they all have these official uniforms that are almost militaristic, almost Navy type uniforms. But whenever anyone of importance comes, they have to don these official uniforms. And they're here with the Princess of Thailand, who is an amazing woman who is absolutely really keen on astronomy. And I think it was really through her that this whole astronomy initiative in Thailand has been so successful and continues to be successful. So I had the opportunity to go there to observe using an instrument called Ultraspec that some colleagues of mine in the UK built, and they do work with high-speed photometry. So it was a nice place to go. It's in a national park in a rainforest. So in fact, when they built the observatory, they were not allowed to cut down any trees. So that's why this whole telescope is on this tall turret here within the rainforest. And when you're observing, you have this sort of graphic to show you where the tree line is, because in some directions you get occulted by a tree, and you want to know when that might happen. As you might expect, in Thailand, it's not like the best place in the world to do astronomy because it suffers from the monsoon effect. So the observing season is really October to May, and it's pretty iffy outside of that period. And now I'm going to talk about some of the places that I've been to in India. And I've started visiting India since 2007 because the institute called IUCA became a member of the SALT collaboration, a partner in SALT. So that's what initially took me to India in 2007. But since then, I've been going for other reasons, in particular, collaborating with some of the people working on the AstroSat project, which is the Indian X-ray satellite. You see it up here. And in particular, two colleagues and friends of mine, KP Singh and Dipankar Bhattacharya. And KP was the project scientist for the soft X-ray telescope, which was being built at the Tata Institute. And so I had an opportunity to go and visit him and also see the instruments being built, like the what's called a LAX PC, which is the high energy proportional counting system, a bit like, as I was telling you, it's not focusing optics for the LAX PC, but the soft X-ray telescope is a proper X-ray telescope. So there were also various other collaborations. I had a visit in 2013 as a Raman Fellow for a month where I was staying at the Tata Institute, which was a great experience. I was just very lucky that at the time I was visiting, the director of Tata was away, and so he offered to give me his penthouse apartment to stay in for the duration rather than the normal guest house, which was very nice, I must say. I've also gone to IUCA, which is in Pune, many times, and seen some of the telescope facilities. They have a 2-meter optical telescope not too far away. Also, the giant meter wave telescope, GMRT, is also there. And well, you can't really see here, but there's a number of X-ray astronomers in this photograph, including Koji Makai, and I think also Diego here, where we're all doing the same gestures as these statues that they have in the garden there of, well, Einstein in this case. I think that's a Greek guy. Pardon? Right. And the other one's Newton. Then I also visited Aries, which is up in the Himalayas, well, the foothills of the Himalayas, near Nainital. Quite a picturesque high town in that area, where there's some quite old telescopes. but also they built a new telescope in Devastal, which is several hours drive away. And so I visited that as they were building that telescope from the beginning until in 2019 when it was actually completed, and it's spectacular scenery there, as you can see. That's the new 3.6 meter Devastal telescope. As it is today, that's what it was like when I think on a second trip. It's built on a hilltop where there is a Hindu temple, which is shown here with bells and things. And they had to come to an agreement with the local priest about where they would build it, and it pushed them to build it as close to the edge of the mountain as they possibly could. So it's got a lot of sort of extra foundations, and they had to do a lot more civil engineering work. But a positive benefit of that is because that's in the prevailing wind direction, it's not getting any turbulent air before it gets to the telescope. So they've had really better seeing than they'd ever expected, all courtesy of this Hindu temple. Also, there's a liquid mirror telescope, which I believe is now operational and was commissioned just recently, 4-meter mercury mirror. Then in 2019, I visited Ladakh, or to the Hanley Observatory in Ladakh, which was my last trip before COVID hit. And this was also a spectacular place. So for the first day there, you have to acclimatize because the observatory is at 4,500 meters. So you really have to be very careful about acclimatizing. I've forgotten what Lay's altitude is, but it's 3,000 something. So for the first day, I did a number of things, including I was asked by the chief engineer and my host from Bangalore to give a talk to students, so to high school kids in this big school hall. It was like -10 outside and there was no heating. And all of these school kids, many of them were bussed in from other schools. There was about 1,000 of them there, all in beanies and scarves and gloves because it was so damn freezing. I had to wear my Russian hat to keep warm. And I gave them a lecture on the solar system because I had lots of really, really neat pictures of, you know, the satellites of the solar system, you know, with the frozen planets, frozen satellites and all of that sort of stuff. And they were all dead enthusiastic and came up and asked questions at the end of the talk. But the very first questions they asked, nothing to do with the planets. They were black holes. That was like, anyway, there's a few of the students there that were at that. And then it was like a 10-hour drive from Leh, that town, to the Hanley Observatory along the Indus Valley, which was quite spectacular. This is all frozen ice in the Indus Valley. Those are some yaks. And that's the Himalayan Chandra telescope, which is a 2-meter class telescope, which observers don't go there. They observe by remote observing in this control room in Bangalore, and they have a dedicated satellite link to do those observations. It's quite challenging from an infrastructure point of view. They have no electricity grid, so they have their own generator and a big solar farm, but that means that at night they only turn the power on for the guest house to make dinner, and then they turn the lights off and the heating and everything off at 10 o'clock at night, and then the temperature just plummets. So I had to go to bed that night with a full like scarf and hat and everything else. But it's a wonderful site. It's the site that's proposed for the new National Large Optical Telescope of India, which is proposed to be a 10 to 12 meter segmented mirror telescope, a bit like Grantacan or Keck. They also have a robotic telescope, part of the growth network for following up transients. And this is just some instrumentation here for measuring atmospheric parameters. My next lot of slides are about Japan. So I was privileged to go there a couple of times, and most recently in 2017. And it was all to do with this Okayama 3.8 meter telescope, which is the first what I call small segmented mirror telescope. So it consists of multiple segments, not like hexagonal segments of SALT or Keck, but these sort of petal-shaped segments which go into this telescope structure. So my host here was Tetsuya Nagata, who was a fellow student at Mount Stromlo. And there you are, there he is, and there I am. Anyway, this has been quite a successful project, and I'm particularly interested because I think this sort of innovative telescope design is something that we could well do with in South Africa, to have a 4-meter rapid slewing transient follow-up telescope of that aperture. They also have existing telescopes at that site, including their own 74-inch telescope, but far more sophisticated instruments, I have to say, than the ones that we have on our 74-inch, including integral field spectrograph, laser frequency comb for their Echelle spectrograph, and so on. And these middle ones are just highlighting the gastronomic things of the opportunity to visit the fish market in Tokyo, where that piece of tuna was apparently $20,000. Then Russia is another place that I've gone to. I've visited the original largest telescope in the world before Keck came along, the 6-meter telescope in Zelenchuk in the Caucasus Mountains. It hasn't been an overwhelmingly successful telescope because it's not in the most optimal place. But there's another telescope, another observatory that's since been built, which is part of Moscow State, Sternberg Astronomical Institute of Moscow State University, and there's the state-of-the-art 2.5-meter telescope that I had a visit in 2015. And then in China, I was invited to the opening of Le Most in 2008 and for a review meeting of the project. And so Le Most is also a segmented mirror telescope, quite novel because it's a Schmidt, so it has 2 lots of segmented mirrors. So quite a complicated sort of thing, but I don't have time to discuss it, but it's, yeah, it was quite interesting to visit. And then as far as Africa's concerned, I've been involved in a while for sort of promoting astronomy in the rest of Africa. Some of it's been associated with capacity building workshops in astronomy in various countries. And then also actual development of observatories. So where's Almir? Anyway, he knows about this, right? So I've been going to Ethiopia since 2009. And I was acting sort of to help drive their development of optical astronomy, which has led to not only the establishment of 2 state-of-the-art 1-meter telescopes just outside of Addis Ababa, but also for site testing in some regions to the north at altitudes of up to 4,000 meters, where there's site testing initiatives to maybe build something even better and even bigger. So the Ethiopian astronomy development started through the Ethiopian Space Science Society, and they really benefited from the fact that one of their patrons was the richest man in Ethiopia and was able to bankroll those telescopes. But it's now expanded to become part of the university system as well, and government funded. And the result of that are these 2 telescope domes on Mountain Toto, just outside of Addis Ababa, with a really nice instrumentation suite. So there's a lot of potential for this observatory to contribute in the future. Then I've been involved also in site testing in Kenya. So this was started out as a very modest project, Kenya, South Africa bilateral project of putting up automatic weather stations to characterize where there might be good observing sites. And this is one we went to, which is not, as we discovered. We might have sort of tumbled to the fact when hiking up this mountain to install an automatic weather station, we're actually going through a cycad forest, which had a lot of elephant droppings because the elephants come through at night, but during the daytime, they go away because there are humans around down on the flat here. And so we established this weather mast. We didn't have a ladder to put the weather station on top. So these guys improvised with various means. And I tell you, I was so nervous that the whole lot would just come tumbling down. And they had to put a fence around it because the elephants apparently like rubbing themselves against any tall structure. So they needed to put a fence up to stop that sort of behavior. And then more recently in 2018, together with a guy who's a consulting meteorologist who's done a lot of work on astroclimate and astro testing, once the UK Astronomy Technology Centre and the STCF became involved, they could sort of fund this a little bit better, which enabled us to go to some better sites in the north of Kenya near Lake Turkana, which is right up in the very sort of arid region. And we were able to have a helicopter for a whole day and went to 3 of the sites where there were MET measurements done in situ at those sites and also from the helicopter. And then most recently, this is a project which got some press last year. I think there was an article in Science about first light with the Iranian National Observatory telescope, a 3.4 meter telescope on Mount Gargash in Iran. And this was, my involvement was in the International Advisory Board that had people from ESO, from Europe and the UK and China. And this telescope, I think, is probably in one of the best sites in that area because the whole time we were there for the design review, the seeing never went below about 0.6 arc seconds for a whole week. And the first light that they got just in November this year was 0.85 arc seconds with the telescope. So, and then my last telescope project has been this one back in South Africa called PRIME, which is a wide field infrared telescope, a joint project with Japan, South Africa, and the US, where the detectors on this are coming from Goddard because they're basically the flight spares of the Roman space telescope. So apparently there's some people here this week working on this. And then just recent initiatives, I think this was alluded to when at the beginning when I was introduced, but I'm also involved in projects to support, for example, follow-up of LSST transient discoveries using intelligent telescopes networked together into a common system, something which Sunil at the SAO is instrumental and has done fantastic work. Using all of, eventually the idea is to network all these telescopes in Sutherland into what's called an intelligent observatory. But furthermore, we are hoping to expand this idea. And so the driving force are the big data generating engines of the future, like Rubin and SKA, and the strong need to be able to do follow-up of sources detected by those. And so one of these projects is to do with BRICS. This is a sort of organization with Brazil, Russia, India, China, and South Africa, but they have an astronomy program within BRICS, and a flagship program was approved, which was called the BRICS Intelligent Telescope and Data Network, with the idea of harnessing, at least from the telescope side of things, all the existing optical and radio telescopes in those countries. And that's expanded into a, well, not expanded, but it's sort of driven a parallel initiative, which is to do the same thing in Africa, to link together observatories in other parts of Africa into, again, an integrated system. So these are my concluding remarks. I think I've gone well over time, but anyway. Yeah, I mean, I've found everything that I've done to be so immensely rewarding. I've been able to work with some amazing people, go to some amazing places, and I'm just feel so privileged that I've had this opportunity. And you know, what I've just found is just being involved in development of telescopes and instruments is really cool and really rewarding, whether they be for our own use or helping others do it. And so that's been something which I've really enjoyed. And I'd just like to finish saying that apart from all of my past supervisors, directors, board members, colleagues, collaborators, I have to acknowledge the forbearance and support of my own family, where the word transient is a dirty word because it's one of the reasons I'm often not on time for dinner, because there's been a transient. But my wife and daughter here, my older daughter lives in Australia with our grandkids. This is Emma, my youngest daughter. She just is in her master's year in biodiversity, gave her first talk at a conference about 2 weeks ago. So I'm very proud of her. And then this is my granddaughter, Delilah, who, well, at that time, she was very little. She's now 6. And with that, I will finish. Thank you.
Thanks a lot. It's really been a very nice journey. I mean, so now time for questions. I'm pretty sure there will be questions.
People want to go to dinner, Sunil, you know, it's like.
Yes, come on.
Thanks for the very nice talk, David. I wanted to ask about the 1.9 meter telescope. So in some of your pictures, there was one in Japan and one in Australia. Are there any more around the world? And were they all made by Grubb?
They're all made by Grubb Parsons, okay. All identical models. So there's one I'm going to see actually next Friday at Kotamaya Observatory in Egypt. There's one also in, I think 2 in Canada that are identical, and one in France. So yeah, it was like at that time in the 50s or 40s, 50s, that was sort of the state of the art. And yeah.
Thanks.
That's a very good life story, Dave. So I don't expect a lot of good observing condition in New Zealand. Actually, it's one of those few countries I haven't been to. How many hours a year do you get to observe with the telescope in New Zealand?
Well, when I started on my master's, I went in May and I had 10 straight days of photometric weather, which in winter, the hours are 13 hours long because of the latitude. So I was utterly exhausted at the end of that, and also totally spoilt because never again did I manage to have such good conditions, which sort of helped me in the sense that in other observing trips, I could go skiing in the daytime and observe at night. And if it was cloudy, it wouldn't be so. Although there were a few times where I burnt the candle at both ends by having a skiing in the daytime and then it was totally clear at night. But because it's in the Southern Ocean and it's got the Southern Alp mountain chain and the prevailing wind is from the west, you get a lot of turbulence and very poor seeing. I think the median seeing is like 2.5 arc seconds. So I once joked with the Japanese colleagues who'd put up the MOA telescope, which is to detect exoplanets for microlensing, which ended up there partly because there's not much of a time zone difference between Japan and New Zealand. And they said they had good sushi in New Zealand as well, and nice scenery. But yeah, it's not the best observing site in the world. But nonetheless, you know, they've got facilities there. Students have had access to, like myself, and so it's still, I think, worth supporting. But in an environment which I have to say, we're so privileged in South Africa to have sort of a government that is so supportive of astronomy. It's not the case in other countries, certainly not the case in New Zealand, unfortunately.
Thank you, Professor, for that wonderful talk. I'm a bit lucky you are also my mentor, but I just want to ask one question. After this long journey, is there some regret that you would like to pass to this young astronomy community?
That's a hard. I'll have to think about that, because there's lots of things where I thought, oh, if only I'd done that, but they've faded a bit. You know, I'm old now. I've actually semi-retired from the observatory, although I have a contract for another 3 years, and I haven't really stopped doing what I'm doing. Regrets? Yeah, that's a hard one.
Thanks, David, for nice talk and experience. My question is, what are you going to advise for African for the development of astronomy in the future?
Yeah, that's a good question. And I think, as you're aware, in recent years, the African Astronomical Society has sort of rebranded, relaunched, and the introduction said I was the chair of the science committee. That's actually James's job as of what, a month ago. What? Oh, you're there. You were there. But AFAS's mandate is to really help science collaborations through the continent, because, as you probably know, and it's not so much for Ethiopia now, but there's many countries where there's only a couple of people, or maybe only one. And it's really hard in isolation to do science, compelling, you know, competitive science. And so what we want to try and do is to bring people together, because these days there's very few things going on in astronomy that are not international collaborations. And so, you know, our hope is to bring in where the resources already are, and where there's a good sort of history, a good sort of tradition of research, like in South Africa, but also in North Africa as well, like Morocco and so on. There's state-of-the-art observatories there. We've tended to be working in silos, though, not so much collaboratively together. So AFAS, I hope, will address that. I mean, I'm going on Sunday to a meeting in Cairo, which is the Middle East and African regional meeting of the IAU. And I'm going to be presenting a talk about the integrated observation system. And I'm hoping that a lot of these observatory directors and people will say, yes, this is something worth doing, because, you know, the combination of all of us is more than individuals. You know, the whole, the sum is better than the parts. But also I would appeal to people here at the workshop from developed world, that there is a real need for big projects to engage with potentially, you know, scientists, astronomers that are not often thought about. And I've been raising this within the Rubin Observatory. there's a whole thing about inclusivity. You know, we talk about inclusivity of different demographics, but we need to be aware of the north-south divide. And these days, with the digital world we live in, and with even in countries that I've been to before, like in Uganda or so, where bandwidth was a challenge 10 years ago, things have improved enormously. And so there's a real, I think, potential there. And I'm hoping that we'll have a special session at the IAU GA in Cape Town next year, where some of the big projects, you know, globally big projects, will come together to present sort of something about their projects and try and sort of interact with potential people within Africa who could benefit from that.
Yeah, just wanted to add that David's effort is also to utilize some of the time from ATOM, which is basically a subordinate telescope of HES. So we are in discussion mode to integrate part of the time of ATOM to our integrated observatory.
Yeah,
plan.
that's right. Yeah, and also ROTC, which is a sort of defunct telescope. But, you know, I mean, at the moment we have this intelligent observatory that you're one of the preeminent people leading that in South Africa. We're saying that these two optical telescopes at the HES site would be the next logical step, and not difficult because they're already robotic telescopes. And so as we've come to learn, even though we have telescopes like the old 74-inch that was built in 1938, and then finally, because of the Second World War, it wasn't finished, but anyway, it's been operating since 1948. That is now a remotely controllable telescope, which will potentially be automated. And so it doesn't need to be state-of-the-art, most modern telescope. You can do this retrofitting. And so that makes all the sense in the world to, you know, bring together all of these telescopes and do that. Yeah.
Any other question from audience? Maybe you can take one online or no? Okay.
All right. Thanks, Prof, for such a beautiful talk and journey of your life. Just wanted to ask quickly, do you have, because I know you've seen a lot of telescopes throughout your life. Do you have like top three? And
have a what?
A list of top three telescopes.
Top three telescopes. You see, you'd always have to go to the biggest, right? So I visited the LBT, which is two 8-meter telescopes in one mount. That was quite impressive. Keck is still really impressive. I've never had an opportunity to go to the VLT, but I think that would be one of the tops, if not the top, actually. But as you all know, there are now these extremely large telescopes that are in construction or planning phase. So that will be amazing when the European extremely large telescope's built in Chile in, I don't know how many years, but that's a 38-meter diameter telescope.
Okay, if there is any last question we can take before almighty load setting affects us. No, so there is a step which is left in this process. Basically, this talk was not only a public talk, but it was like a kind of a talk which is supposed to honor David and his tremendous efforts of building up multi-wavelength astronomy club in South Africa, and also enriching it over Africa and beyond. So in this line, I would like to request Professor Marcus Butcher to gift some of the souvenirs from NW. It will be good from that side. You can just give one. by one, and then he will. Yeah, he will hand it. Oh. Sorry. Oops. Thank you very much. So it will be thanks, Marcus. It will be incomplete if X Vision is not gifting anything to David. So I would like to request Matteo to gift Anton. Matteo to come forward. It's a unique gift which will be going from your side to David.
Yeah, and I choose it, only several days to choose exactly.
Thank you very much. Thank you. That's it.
Yes. And thanks a lot to Anu, Pranjopriya, and Anton for arranging all this. Thanks a lot.